So we did the permutations lab. You guys want to do the combinations lab?
Yeah.
Yeah.
Okay. Okay, let's dive into combinations. We saw order was important. Cracking a code is an example. What if order doesn't matter? All right, in the previous lab, we created a factorial function. Now let's use this function to create combination as well as permutation, both holding two arguments n and k. All right, that's easy enough.
You close the drawing window so I can read it.
My bad. Hang on, I'm gonna go to the solution. All right, so the permutation function, that's easy enough. It's just using factorial to, yeah, it's just plugging in. It's the subset one. And then we have combination, which is same thing. It's just using the factorial function to build out the formula for combinations. Easy enough. Okay. Flatiron School is holding a mini mathematics contest, and there are 9 people in the last round. Imagine Flatiron School is giving out bronze, silver, and gold. How many possible ways are there to create this top 3? Okay, fair enough. It's just okay. So just permutations. So from 9 people, we want to select 3 people, and order is important because it, who's going to get the bronze, who's going to get the silver, and who's going to get the gold. So that's why we're using permutations of a subset. That makes sense, right? All right. Imagine Flatiron Schools granting the first 3 contestants a massive fruit
Can you
basket.
scroll up to the permutation? The
Formula?
Permutation, yeah, that.
Yep.
Factorial. Okay.
Yeah, that's this one right here. It's going to be shady, but all right. So do you see this? Permutations of a subset. Is it mirrored or is it? Can you read it?
No, that's pretty small. It's just a little tiny square on my screen.
How about now?
Yeah, sort of.
That's
Yeah.
that's the formula for permutations of a subset, right? So if you have a pool of n items and you want to determine the number of possible ways that you can pick k items from that n, you use that formula, which is just n factorial over n minus k factorial. And this is just a classic example of that down here, where they have 9 people, and from those 9 people, they want to see how many ways can we select 3 people, right? So, and order is important. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We want to select 3. We can select 4, 7, and 8, or we can select 8, 4, and 7, Keep going?
Yep.
All right. So now it's like, okay, imagine Flatiron Schools granting the first 3 contestants a massive fruit basket. How many ways of selecting 3 people are there in this case? Now here, order doesn't seem to be important. Over here, order was important because, the first person gets bronze, silver, and then gold, right? So which one comes first? He'll get the gold or the silver. But here, they're just selecting 3 from a group of 9, and order is irrelevant. So it's just unique combinations, unique ways of getting 3 people, and there's fewer ways. I think there's fewer ways to do that and we're just going to apply the formula for combinations. So we're going to do the combinations formula. 9 is the pool of people to draw from. 3 is the number of units we want to pick from that pool. So we're just going to plug that, and it's going to give us that there's 84 ways that we can select 3 people from a pool of 9, and order isn't important. Anybody want to scroll up to the combination formula again? It's factorial n over factorial n minus k multiplied by factorial k. And that's this formula right down here for combinations. It's in the lectures, but that's the one, basically. All right. Keep going.
Yep.
Some more practice using combinations. Imagine that you have 6 different consonants and 4 different vowels written on pieces of paper in a bag. You will draw 5 letters out of the bag. What is the probability that you draw exactly 2 consonants and 3 vowels when drawing 5 letters? Write the code for getting the total number of ways of drawing 2 out of 6 and 3 out of 4 below. Right? So, yeah. Yeah. So now here they're just seeing the possible combinations of vowels and consonants. So they say, you know, from 6 consonants, we want to pick 2. How many ways are there to do that? From 4 vowels, we want to pick 3. How many ways are there to do that? And then there's the total number of ways to draw 5 letters out of 10. Doesn't matter if they're vowels or consonants. So they're doing combination 10, 5. Now the tricky part is this one. The probability of drawing 2 consonants and 3 vowels when drawing 5 letters. And so what they're doing is they're multiplying the number of possible combinations of consonants multiplied by the number of possible combinations of vowels, and they're dividing it by the total number of possible combinations. That makes sense, right? Because the sample is your sample space. That's just all possible, you know, ways to select 5 letters. And then here they're just multiplying the ways to select consonants with the ways to select vowels, and they're that is your event space, right? Those are the outcomes where you draw a consonant. Those are the outcomes where you draw a vowel. You multiply them together, and that gives you your event space. So that's the sample, and that gives us your probability of getting 2 consonants and 3 vowels. Does that make sense?
Yeah.
Keep going. All right. Out of 6 consonants and 4 vowels, how many words with 2 consonants and 3 vowels can be formed? You can reuse a part of the previous exercise. All right. How many words with 2 consonants and 3 vowels? Oh, okay. And now we need to take into account that order is important, right? So here we're just pulling together the consonants and the vowels. So we're picking 2 from 6 and 3 from 4. And that's just giving us it's like Scrabble, like you're just pulling them out of the bag. And then once you have those combinations, you can further trying to see how many ways can you arrange 5 letters, and that's just factorial 5. So the total number of words with 2 consonants and 3 vowels then equals draw the number of possible ways to draw consonants, the number of ways to draw vowels, and then just multiply that by the number of possible 5-letter arrangements. That makes sense. Yeah. Keep going.
Yep.
All right. We're holding a mini soccer tournament. 16 people participating. We'd like to form 4 teams of 4. How many ways are there to do this? Okay, 16 people, 4 teams of 4. Okay. All right. So first they're pulling 4. Oh, that makes sense. So first they're pulling 4 people from 16, which leaves them with 12, and they have to pull 4 more. That leaves them with 8. They have to pull 4 out of that. They have 4 left, and they have to pull 4 out of that. And then they just multiply all of them, and that gives you your total possible combinations. Pretty straightforward, right? Next one.
Straightforward when they give it to you, but not when you have to figure it
True.
out.
That's very true. Yeah, when you're looking, yeah, you're right. You're right. Yeah, yeah. That's tricky, right? Because like you'd have to bear in mind that like if you're trying to form teams of 4, like each time the pool that you draw from goes down, and then you have to multiply them out. You're right. Yeah. Next lab.
Yep.